So yesterday we were studying theory, like theoretical part, and that was like more of an interview perspective thing. Like if somebody asks you, what do you know about a production grade server? So how do you respond? How should you respond to that question? Today we are going to look at the specific parts of our the main.go server file, and first I will go with the rate limiting in the production Go services, then the recovery, and then the remaining part, like which is here. And today I created the Notion document, like just copy pasted things, because in the IDE we are having that lagging issues and I don't know how to solve that, so I just did this extra effort and I created a Notion doc which later I can share with you. So but like there is no point to share, but yeah, if you want I can share, because you already have the repository and this is nothing but I just like a code snippet from the repository. Anyways, so yeah, so let's start with the rate limiting. So yeah, this part is very easy. What is rate limiting? Yeah, of course, like something to restrict the resources and make a fair uses for everyone. That's basically. So it's still in your server, like no matter you are doing it in Go or Python or Java, like wherever. But of course, every language like has their patterns. In the Spring Boot, we have like controller, services, repository. So controller are handlers there, and then there's a config and like middleware. So in the handler part, there should be a middleware which intercept your request as soon as it arrives to the handler, because before that, of course, you can't intercept it. So interception happens between the router and the handler in Go. But when it comes to Spring Boot, like there's controller, so you hit that route directly and then you implement and then you apply the that middleware. So in your handlers, basically you just need to put some restrictions for the rate limitation, because handler is the one who is going to call the services in Golang, and then services is going to call the repository after the business logic. So if you want, so most of the time you just want to save your services or the database, because service contains the business logic and database contains, of course, like the data. So you just want to block a request to reach there, depending on like if it's a rate limiting or the attack. So yeah, there are various patterns which you can use while performing the rate limiting, but in our case we are using one of them, which is like very smooth and easy to implement, easy to understand. But yeah, today I have few very advanced rate limiting methods which you won't be finding most probably anywhere else. So we will look into that. Let's just wait a second, 1 hour and break. Yeah. It feels good. Okay. So token bucket algorithm, there is a little visual representation which I created. So now assume that we have a token. Like token is nothing but empty struct with the like 0 bytes. So like it's like a space, like okay, a vacant space. So we have a token bucket, and the token bucket itself has a capacity because it's a bucket, so it has to have a capacity. And let's say 10 tokens, and refill mean, of course, you have, because rate limiting means just wait for a few seconds, then allow users to make request again. So we are just limiting, not the blocking completely. So you have to refill. So 5 tokens per second mean like every 1 token per 0.2 seconds. If this like math, that's good. So time as you second, you have 1, 2, 3. In this particular context, when I'm saying blocking, I'm saying like completely blocked, and limiting means just limiting for a certain period of time. Of course, you can say we are blocking for a certain period of time. So there is no difference. There's like different vocabularies. 1 2 3 4 5 6 7 8 9 10 10 tokens we have. So at the time 0 second, full bucket 10 tokens. Okay, if you don't understand this representation, then you won't be able to implement it by yourself. So this is very important. So let's say request arrives at time 0 second, and we take one request, mean like one token out of it. So like one token mean one request. So you take one token out. Okay, so this okay because like you are allowing, because you are having tokens. So okay, fine, good. Then at the time 0.1 seconds, now you have 9 tokens. Let's say 5 requests arrive. So take 5 tokens out. So now you should be having like 4 tokens only. But at the time 0.2 second, we have 4 tokens, of course, but 1 token added. Why? Because it's 0.2 second, and the calculation says that 5 tokens per second, which equivalent to 1 token per 0.2 seconds. So we have 5 tokens. Then at the time 0.4 second, let's say again 10 requests arrive, but we have 5 tokens only, but the request number are 10. So here we have to limit or block, or like not block, but reject the 5 requests and accept the 5. So only 5 succeed, green tick, and the 5 rejected, red mark. Again at the time 1 second, we have refill to the capacity, which is 10 tokens. Now tokens can be 1000 or 10,000 or 100k based on your logic and the requirement. That's simple. So this is very simple representation of token bucket algorithm. So you have a rate limiter struct, you have a rate, bucket, ticker, stop channel, and the wait group. This ticker is nothing but just like a timer. Like in Golang we have this. We don't have to use any external dependency. We can directly use it with the time pointer. So ticker mean like every 5 seconds or every 3 seconds, like do this particular thing. So we have to tick that, and you're like in the for loop, your select statement can listen for it and then can perform whatever you want to perform on that tick. So this is a simple struct. Of course, you can add many more values here if you can think of them, and based on your implementation and the service logic. So why we are using channels here? Of course, why I added this thing, because I just want to let you know that you can do it without the channels. In that case, you have to use mutex, and you have to lock for every single operation, and every single operation mean every time you are allowing a request to take a token out, you have to lock that token variable for that instance, and that will give you latency, that will give you a slow operations, because you have to lock. And when you are locking it, you have to block all other requests or the people to don't let them access this thing. If you use channel, like buffered channel, then of course you don't have to block anything, or it's lock free. And because we use channel, like channels or operations are atomic by default when you work with them, so you don't have to lock it. So anyway, for those who don't know what is path, is specific path based rate limiting. Basically you just like, of course you put as a like rate limiting as a whole, but sometimes, or like most of the times, especially in fintech maybe, or like the data intensive platforms, you put or you try to implement the path, specific path based rate limiting. Basically, like if there's like get request path, so you can like just give it like 1 lakh maybe. For example, if there is some like computation is involved, then 10,000. Like if you want, like if there's a path to upload some data, or like to render some like images or videos, whatever it is, then you just do the 100. So if you don't know path based rate limiting, then it's hard to implement such things, and this is a very basic need for any intermediate level of platform or the application. So here, so different limits for the different points. So just create a map, which is like the key will be the path and the value will be the instance to the rate limiter, because if you do this, then you can access all the values inside the rate limiter, and this way you are creating 3 instances of rate, the 3 copies of the rate limiter with the different values, like 3 instances. So this rate limiter configuration will be working based on this value for the compute this path, for this path this will be working based on this value, and so on. Then you can do one thing like per user rate limiting. Then you can create a user rate limiter struct, limiters map string again to this, read and write mutex, allow method which decide like whether you want to allow user or not. So you just provide the user ID and you do further calculations. Fine. There is one more thing which is very interesting, that adaptive rate limiting. I like this method very much, and I want to specifically implement this, not today but some other time. And it's like similar to the adaptive concurrency we have talked yesterday maybe, or like in our earlier lectures. You decide based on the error rate. So the base rate, let's say 1 lakh. Then if error rate is greater than the 0.1, like the 10% of the errors, then you just reduce the base rate and go on, and then you return that. So it's nice to do things adaptively. It's like similar like to you when you watch videos on YouTube like 720p or the 180 or the 4K. So that's it. So for this specific thing, because like if I just tell you this, then maybe you don't get it, like how to actually implement this. So I just extended the implementation for this part, the path based one. So let's go down here, specific cases. I think this is specific cases, single per endpoint rate limiting. So now let's